Good morning, it's Thursday of week 3 of your Physics 5 a day here, and we're on superposition and stationary waves today, so some heavyweight waves topics today. Starting with superposition, if you have two or more waves that are overlapping, then at any particular point, what will the displacement be at that point? Well, it will be the displacements of the individual waves added together. That's what we mean when we say that the waves add up. This is called the principle of superposition, and it is always 3 marks. So you say that when waves overlap, first mark, they add up, second mark, and the resultant displacement at any point is the sum of the displacements of the individual waves, third mark. The first part of this question is finding out what that resultant displacement is at 2 particular times. Just remember that displacement is a vector. So here we've got positive displacement and here we've got negative displacement. And then the last part of the question is a nice tie into intensity from yesterday. Okay, pause the video and have a go now. Okay, so at t equals 1.5 milliseconds, the displacement of both waves is 0, and so the resultant displacement is also 0. And then at 2¼ milliseconds, we've got a displacement of -2 for wave S and a displacement of 3 for wave T. So adding that together, we get 1 micrometer. I really like this next part of the question, which I'm going to try and squeeze in up here. So we've got the wave S passing through the point P and also the wave T passing through the point P, but we're asked to consider them separately. So imagine that just the wave S was passing through P. Then the intensity, we're told, is I. Okay, so we know that intensity in general is directly proportional to the amplitude squared of the wave hitting it. And so we can say that intensity is equal to some constant, which depends on the situation, times the amplitude squared. Okay, so if we just had wave S, we're told that the intensity, if we've just got wave S, we're told that the intensity is I, and then we don't know what the constant is, but the amplitude of the wave S is 2 micrometers. Now I'm ditching the units because it's the same for both, so I'm just going to put 2 squared in there. So I find that I is equal to 4k, and k, so now we do know what the constant is, it's equal to I over 4. Now thinking about what would happen if we just had the wave T. Well, the intensity then would be the same constant, because it's the same type of wave in the same situation, so the same constant, but the amplitude of the wave T is 3 micrometers I should say, and so that means that the intensity is going to be 9k, but we know what k is, it's I over 4, and so that means that the intensity, if you just had wave T, would be 9 over 4 I, and that is 2.25 I. Okay, but we don't have just the wave S arriving or just the wave T arriving. We've got them both arriving at the same time. So the actual intensity is depending on the amplitude of the resultant wave. So we need to add these 2 waves together. So if I'm going to draw it on the bottom one here. So we've got at the start 0 plus 0 is 0. And then -3 plus 2 is -1. And then 0 plus 0 is 0 again. Then 3 add -2 is +1. And then 0 add 0 is 0 again, etc. So you can see that the resultant of the 2 waves is in here. And so we can see that the amplitude of that wave is 1. And so the intensity of the resultant wave is going to be Ka squared. K is, from the previous part of the question, I over 4, and A is just 1. So the intensity of the resultant wave that we're going to write right down here at the bottom it says in terms of I, so we're going to write I over 4 in there. Well done if you got through that. That's quite tricky.